I'm Robert Cozy. I'm the publisher of Canadian Contractor, and we are here again at the ITW warehouse where they have a test facility. And we're going to show you some of the tests that they conduct on their fasteners. I'm here with
Andrea Galindo.
And I'm here with Andrea Galindo, and she is the technical specialist that will help show us exactly how these tests are conducted. Andrea, what are we looking at here? What is this machine?
All right, so this is a United Speedy tester machine, and we use this machine for testing the tensile strength of materials.
The tensile strength, and what does tensile strength mean?
So it's the maximum strength the metal in this case can hold in terms of pounds of force.
Okay, so that means you're pulling it, you're basically pulling it apart this way.
Exactly.
Like I can imagine there must be an awful lot of tensile strength in here. What are we expecting the screw to hold up?
So it varies. It depends on the size and on the length of the screw itself. For this case, we'll be testing a 3/8 by 4-inch length RSS GRK screw, which you have in your hand.
Yep.
And so the ultimate tensile strength for that screw will be approximately 5,900 pounds.
Okay, now that is, I think you were telling me earlier, that's the average number that you should expect for across a number of tests. Is that correct?
Exactly.
Okay, so some might be a little lower, some might be a bit higher.
Right.
Now, my understanding is that there's a test strength. What did you call it, an ultimate strength?
The ultimate strength is when the tensile will break.
When it breaks, but
Yeah.
then there's a usable or
Allowable tensile.
Okay, and the allowable level of strength in a screw is what gets published, and what the contractor would need to know when he's using this particular screw.
Exactly. So the published allowable steel strength is 1,914 pounds.
1,900, so around 2,000 pounds. So we've
Yeah.
got a screw that will break at 6,000 pounds, and the allowable use is 2,000 approximately.
Yeah, approximately. Yeah.
Okay, so that's really 1/3 of the breaking strength.
Exactly.
That's really interesting.
And
it's
that's a
good to
safety
know.
factor.
That's a big safety factor. All right, show us how you're going to test the screw.
Right. So we take the screw, turn on the machine. All right. So we take the grip. We insert the GRK screw, and we want to have the washer flat, as I mentioned before. And we open the grids. Right, so now we're going to reset, so we have the load at approximately at 0, and as simple as that.
Oh, now it's actually started?
So
Oh, I can see the loads going up.
load
It's at
is
223,
increasing.
4, 5, 9. Whoa! Oh! Okay. All right. I'm good. Okay, so we look at this, and now the test, the screw broke at 5672.8. And the approximate number we're looking for is around 5.9.
right,
Okay.
5.824.
5.824, okay.
Yeah.
So now that's a little lower than what the expectation is, but you would do 5 screws. Like, tell me a little bit about an actual test.
Right. In any case, at least we will do 5 samples. And then from those 5 samples, we'll take the mean average, or the standard deviation, and the coefficient of variation.
Okay, and then that will tell you whether or not this batch of screws is actually meeting the standard, the expectation that you have.
Right.
So if you
Correct.
discovered that the general information that you got was lower than the standard, then you would go. What would happen from then?
So we return the samples, and we talk to our headquarters, where they have a full-scale lab in Chicago.
And so they find out, why is these screws breaking at this level, and then they start to look at the formulations that they're using or the systems that they're using to discover whether or not there are changes that need to be made to make sure that the screws get back up to strength.
Okay.
Wow, that was really great. That was very interesting. I didn't jump. I did a little bit. Next time we're going to do a pull-through test. I understand.
Right.
And I want to talk a bit more about the mechanics of the construction of the screw, because it's really interesting to find how exactly you make sure that you get the kinds of tensile strength and other strengths that you need. If you have any questions for us, then please send your questions to the email at the bottom of the screen here, and we'll definitely follow up. Thank you. And maybe we can answer the questions next time on the ITW video. So happy to hear from you, and thank you very much for what you showed us.
No problem.